Hi, my name is Kylie Loveday, and today I'm going to be delivering this mini lecture on scatterplots. Scatterplots are a graphical way to show the association between two variables. So here we have a graph panel. With correlations, we always put our explanatory variable on the x-axis for horizontal axis. Our response variable goes on the y-axis. In the center, we represent values for each individual by a dot. The dot will be placed horizontally and vertically relating to their score on the two variables. So let's use our example that we talked about in the last mini lecture, where 81 students were asked about hazardous drinking behaviour and about their stress levels. So we put stress, our explanatory variable, on the x-axis and hazardous drinking behaviour, our response variable, on the y-axis. And for each participant, we add a point for where they lie on the stress variable, 9 for participant 1, and on the hazardous drinking variable, 12 for participant 1. For participant 2, we add a point at 2 on the stress level and 4 on the drinking level, and so on, until we just keep adding everyone, and we have plotted all 81 participants. And we can look for the following features in a scatterplot. Form. Are there clusters in the scatterplot? Direction. Does the data tend towards a certain diagonal axis? And strength. Do all individuals closely follow a pattern? So here is our stress and hazardous drinking. While no clear breakaway clusters of data are present, you can see that most of the data is down towards the lower left corner. Most people are low on stress and low on hazardous drinking behaviours. Next up, we have direction. Is there a diagonal axis to the data? We can actually fit lines to our data, but that is something we'll get to. Here, the data seems to go towards an upwards diagonal direction. And there are two types of directions. A negative association depicts a trend from the top left to the bottom right of the scatterplot. Above average values of one variable tend to be associated with below average values on the other variable. As you increase on one variable, the other variable decreases. A positive association, on the other hand, shows data in a trend from the bottom left to the top right of the scatterplot. Above average values of one variable tend to be associated with above average values on the other variable. And lastly, we can look at a scatterplot to determine some measure of strength of association. A weak strength relationship will have data quite broadly scattered around a plot, even if there is a tight directional tendency. With a moderate strength relationship, the data is more tightly clustered. A strong relationship shows a clear direction as the data is tightly clustered around an imaginary line. Now, one thing to bear in mind is that we can actually change the appearance of strength in a data set by changing the scaling. This data here can be made to look like a much stronger relationship by extending the x and y axes like this. Another thing that we want to check on our scatterplot is whether there are any obvious deviations from the pattern. These two data points score very high on hazardous drinking behaviours, but not very high on stress. If there is a positive relationship, do these 2 points constitute as being abnormal to this pattern? Here is a more obvious example of a deviation where one individual smokes a lot of cigarettes but has a high life expectancy compared to most people who have a lower life expectancy with an increase in the number of cigarettes smoked per day. Now, scatterplots can be examined further by using the line of best fit. This allows us to fit a mathematical formula to our data to give some indication of direction, strength, form, and deviations. You can generate a line of best fit in SPSS by double-clicking on a scatterplot to bring up the chart editor and clicking on the Add Fit Line at Total button on the toolbar, which looks like this. You can also access this option by selecting Elements, then Fit Line at Total from the menu bar. Ensure that there is a bullet point next to Linear in the Fit Method section of the dialog box that opens to give you a linear fit, and then finish running to generate the line. The line that is added to the data is called a linear regression line or a least squares regression line. The line can be described mathematically, and it can also be used for prediction. For example, if we know someone has a stress level of 17, we can read up to the line and along to get the predicted hazardous drinking score of 13. Note that this only works one way. Just as a quick side note, there is a slight visual illusion in this plot. The horizontal red line appears slightly angled, but if we move it down, that shows it's horizontal. Now, the regression line can actually be extended to include more variables and to give greater predictive power, but you will learn more about that in a later course. 3003 Sci. So the main points of the mini lecture are that scatterplots allow us to visualize data. We can check for the form, direction, and strength of associations. There are numbers that give us a better idea of these, but visualizing the data can be useful. We can also use scatterplots to see if there are any obvious deviations from the general pattern of the data. And lines of best fit can be plotted on data to allow us to make predictions based on a variable, but more on that in 3003 Sci. Thanks for listening to this mini lecture.